Let's see a typical use case of the FSP integration with the Mojaloop scheme. Here, there are two FSPs. One is sender and one is receiver. Let's say both uses payment manager to connect to the Mojaloop system. So they need to develop a core connector to connect to their core banking solution. So in case of sender, this core connector here should support the outbound API calls. In case of receiver, this core connector here should support the inbound API calls. So to act as both sender and receiver, a core connector should support outbound and receiver, outbound and inbound API calls provided by the payment manager API specification. Let's discuss the core connector development for an outbound transfer. So in this case, sender FSP, this core connector here should support outbound API calls to the payment manager. So if we use the on-premise deploy repository, that simulates the Mojaloop and payment manager with the testing toolkit. So the receiver side payment manager. Let's say the core banking system here triggers a transfer by asking core connector. Then the core connector should call the HTTP API for the outbound transfer on 4001 port of the payment manager. And then payment manager sends FSP request to the testing toolkit. And then testing toolkit responds with some mock responses. And payment manager responds with the synchronous HTTP response to the core connector. And then core connector can notify the core banking system. So this is a typical outbound transfer flow through the core connector. Let's see how to run the payment manager locally for the outbound core connector development. So this is the on-premise deploy repository. You can have a look at the README file. Just scroll to the this section, developing your own core connector. So you need to clone this repository and Docker compose up. This will start all the services like payment manager related services and also a testing toolkit for simulator responses. And then you need to open this web page, TTK web UI, for monitoring the requests. When you trigger a transfer from your implementation, you can see the inbound requests as a Mojaloop switch. So TTK, because TTK is simulating the Mojaloop switch, you can see the FSP IOP related API requests on this page. So let's try this. I already cloned this repository. So I am in on-premise deploy directory and go to Docker compose. And then Docker compose up. Okay, let's open the testing toolkit monitoring page using this URL. So this is the monitoring page. And according to the documentation, let's execute this command line HTTP request. So this is a call request from the command line to make a transfer. So in the core connector, you need to implement the same request using the programming language you choose. So let's execute this. So a transfer happened, and this is the response in the command line. This is a JSON response for the transfer request. And you can see the transfer state here is committed. That means the transaction is completed. If you want, you can use your choice of HTTP client like Postman or even testing toolkit to execute the same request. So let's see the inbound request on the TTK. On the monitoring page, you can see we got get parties, post codes, post transfer from the payment manager. So here, the curl command we executed called an endpoint in the payment manager. Then payment manager converts that synchronous HTTP call to the asynchronous three-phase transfer and made that payment. So there is a point here. The payment manager executed the whole transfer, three-phase transfer with a single request because the auto acceptance of the parties and codes is set to true in the payment manager configuration. That's why it automatically accepted the party information and then code information and executed the transfer in a single HTTP call. We can change that. If you see the documentation here, testing three-phase outbound transfer from core connector. So you need to change these parameters in the Docker Compose file, auto accept code and auto accept party to false. And then if you execute the same transfer request, this request, HTTP /transfer request, then it gets the party information first, and then you need to accept that by sending a follow-up request, put transfer request with the same transfer ID. The content is accept party equal to true. And then it gets the code information as a response to this call. Then you need to execute another put transfer request with accept code equal to true. So this is for three-phase transfer. So let's execute the three-phase transfer from the payment manager. So we need to set these parameters to false. I already set them. I can show the file. Docker compose.yaml. Go to accept party. You can see both values are false now. I restarted the Docker Compose after setting these parameters. Now we can execute the same transfer request. So this is the same post transfer request. And before executing this, let's refresh the testing toolkit UI to clear the history. So let's execute this and see what happens. You can see the response is much smaller, and we didn't get the transfer fulfillment here. We only got the party information. And let's see the request on TTK. You can see only we got one request in TTK, which is get parties. So it is waiting for the party acceptance. To accept the party information, we need to make another call with the transfer ID. So we need to note down the transfer ID from this response, this one. and then copy the put transfer call here and replace the transfer ID string with the actual transfer ID. So this is a put transfer call with accept party equal to true, and execute this. And now we got the quote information. So you can see the payee information and also the quote information here. Yeah, here it is. Payee receive amount, fee. Let's see what is happening in testing toolkit. You can see now there is a post quotes call. Now we need to accept the quote. We need to send the same put transfer request again with accept quote to true. So same put transfer with the same transfer ID with accept quote true. And then the payment manager continues the transfer execution. And now we should see the transfer state as committed here. Now transfer happened. Here we got post transfer in the TTK. So this is a three-phase transfer.